Thank you. So, yeah, in this talk I will present gaze plus pinch interaction in virtual work. And this was conducted at Lancaster University with my colleagues Benedikt Meyer, he's from the LMU Munich, he was an intern, and Diako, Mardanbegi, and Hans Gellersen. So, the previous talk was really studied how eye gaze works right now, and it showed off some of the limitations. But in this talk it's slightly different, so I'm not running a study, I'm not comparing anything, I'm looking into exploring what can we actually do if eye tracking would work really well, and but also what can we do right now with the current limitations. So, okay, I want to start with an example here. So this is like the typical VR scene. So there are two objects here in the scene, and so this circle here, the gray, okay, you can't see my mouse cursor, but in the middle there's this green, gray circle, and that shows or indicates where I'm looking throughout all examples. So I'm just going to run it, and what you can see is I can, in a very dynamic way, I can manipulate these two objects, right? And so I'm not using controllers, even if the objects are far away, and somehow I'm using just my bare hand, free-handed input to have this very flexible way of interaction. And I want to explain you this kind of interaction and explore it further in the following. So to give it a little bit of structure, first the background, then I'll explain how the interaction works while we implement it, then give a few examples on new ways of manipulation, and in the end also how we can integrate this kind of interaction into more sophisticated user interfaces such as menus. Okay, so this work is similar to the previous one. It's at the intersection between eye tracking and virtual reality. So I guess I don't have to introduce too much here, but let's just say my perspective is, so I did a lot into eye tracking before that, not in virtual reality, and one can separate this into these two categories here. So gaze interactions since the 80s, 90s. So gaze has been often used as a pointer to indicate the target, and most of the studies, like the previous one, say, okay, gaze really fast, there's less manual effort, but of course we have issues with inaccuracy, possibly from the Midas touch problem, but most likely from hardware issues. But in that sense, I would say that in the previous years, eye tracking improved significantly. So I think there's a bright future in a way. So, but I'm not focusing on that aspect too much in this paper. Yeah. So on the right side, you see works that have combined these two modalities, and there's been a lot actually in combining gaze with like keyboard input, with different kinds of mouse and cursor interactions. And what I did kind of recently is looking at multi-touch with eye gaze. And I was just interested, okay, how would this kind of interaction, this multimodal interaction work in virtual reality? And looking into literature, there's a lot into like this gaze-based interactions. There's been work done with dwell time and rays and different kind of menus, or the previous talk. But there hasn't been a lot of work that explored actually what can we do if we join the powers of the hands with the magical, very fast way of eye gaze. So that's the focus of this paper. So I looked into the virtual reality literature, and specifically in HCI, and one paper I found really interesting, the one from mine, Virtual Environment Interaction Techniques. And so there he said that before we can actually create a virtual world solution, we must identify natural forms of interaction and extend them in ways not possible right now. So focus is on what is actually natural and what is not possible right now. It's also kind of referring back to the keynote yesterday, where it was also discussed what is natural and supernatural, and all these kind of exciting interactions. So he kind of separated the space into there are these virtual hand interactions where you directly manipulate objects. You can just simply use your hand, and this kind of goes back to the skills that we've learned when we grow up. We know how to grab things, we know how to pinch things. It's very easy to use. And on the other side, there are these pointer interactions, right? Because in a virtual environment, we have a lot of space, and we want to interact with all these objects around us that are even out of the normal manual reach. And yeah, there's been a lot of work into that either focused on one of the sides or kind of combined them. I'm not going in too much detail, and because we also see them right now in products, like the Leap Motion using hand gestures, HoloLens is some kind of variation there. And Oculus, PlayStation, and HTC, they have these ray pointing metaphor where you can control remote objects. And I think it goes down to this trade-off here. So we have this trade-off between more natural interactions where you just simply use your hands as if you would use them in any normal physical interaction. But if we want to interact with distant targets, we need to have some kind of other metaphor. And usually it's using a controller, a ray pointing metaphor, and that, of course, you need to hold the device and know which button does what. And this is not as intuitive as if you would use just normal free-handed input. So what is the proposed interaction here? So what gaze plus pinch essentially means is that you can look at any target and use pinching gestures to manipulate such a target. And the interesting part here is that these freehand gestures are quite natural. So as I've already said in the previous slides, so you can freehand gestures, very easy to do, intuitive. But at the same time, it's not really natural. It's more like supernatural because you can interact with anything you're looking at, right? So whatever is in the virtual scene, you can select it by just simply looking at it. And this is how these are like the basic principles how we implemented this. First of all, the most important one is that hands do the work. So wherever you're looking, nothing happens. You can look at anything as long as you want until you perform a pinch gesture, and then you get the mapping, and you can move an object. And yeah, two more things to consider. We used target snapping, so the closest target to the user's gaze ray is always selected. So this way we can kind of explore these interactions without thinking too much about inaccuracy and maybe potential errors there. And the second aspect here is there's a one-to-one translation between hand movement and the object that you have selected. So when you move your hand, it will look like as if almost the target moves in the same way. So a few notes on the system. So we used an HTC Vive with a Leap Motion attached to it on top. And inside there's a pupil eye tracker. The user's calibrated before the interactions. And usually this works quite well, the eye tracking as well, if the head HND is also well attached to your head. So if it moves a bit on your head, it gets calibration drift and also. But usually it works sufficiently enough. And yeah, the virtual scenes are developed with Unity. Okay, so I want to talk about the design space. So there are the atomic interactions of gaze and pinch. So we can interact with one or two targets in this space, but also with either one or two hand. And I want to give a few examples from this. So here in this video, hope you can see well. So here the gaze cursor is again shown as the gray circle. And so I can just simply look at one of the objects and move it with my hands. And if I want to interact with two targets, and this is also quite easy. So I just look at the first target and I look at the second target and do something, as you can see. And okay, by manual interaction, this is also quite seamless. So you just look at a target and you can engage the second hand at any time if you want to do some rotation and scaling. So it supports all these typical 3D manipulation tasks. And of course, you can also interact with two different objects at the same time. If you're holding one, and then you look at the other one, and then you can use the second hand here. And the key to this is actually that all of these atomic interactions, the user can switch between them, right? You can engage one hand, you can put them out, and just manipulate anything you want for these three tasks of rotation, scaling, and translation. So that's why I want to show you full video here. So imagine some kind of interior design scenario. So here I'm rearranging the living room, and I can quickly change between scaling or changing rotating the table in a way that I want it. And in a few seconds, I've kind of moved around a few objects and have had a new design in this room. So, okay. So this was about the atomic interaction, but what can you actually do with this, and how dynamic can this become? And this is especially interesting compared to, okay, how would this be possible using the controllers, or if you would only have the deep motion, for example, and you would only have your hands to interact with it? And these are the questions that I always find interesting. And I looked into 5 different examples. So in a sense, I just played around with this interface and tried a few things. And first of all, this is what you've seen at the beginning. It's the juggling one. So what it really nicely shows is that it's very easy to switch the context between 2 different objects, and just, this is a very time-critical task. Although it seems very easy, but you need to exactly coordinate your fingers and your vision. But since you're looking at the ball that you want to juggle anyway, it's quite simple to coordinate this and do that until this point here. Okay, but let's go on. So another interesting aspect is that you can play with the scale on a really large scale. So that was not good wording. But as you see, there's a small object quite far away here. And I can resize it, make it a bit bigger. So it's maybe a few meters in front of me. And so this scenario here has objects that have some kind of kinetic behavior. So they behave like basketballs in a sense. Just to give you to make so that this example makes sense. But the idea behind this is that you can play with scale. So this object is quite far away, but you can scale it again up into a very large size and use it even for to manipulate the whole scene, even if the towers are really far away here. So it gives you quite a wide range of control for 3D manipulation across the scene. So another example is about more scattered interface. So imagine there are a lot of different objects around, and like in this one, and here I just want to sort them, but it could be any kind of more cluttered virtual scene here. And every time I'm just looking at one of the targets and I'm moving them around here. So this has a specific interaction attached to it, but it could also be freehand 3D manipulation somehow. And in a few seconds, I can just easily sort all of the objects with that. So imagine you would have to do that with head orientation or using HoloLens or something like that. So moving the head to each of the objects on the scene, that would be quite tedious in my opinion. Yeah. Okay, so another thing that I found interesting here is the power of bimanual interaction. So there's been a lot of work in bimanual interaction that you looked at this dominant hand, non-dominant hand interaction. And what I'm doing essentially here on the left side, with my left hand, is I'm holding this pile of objects here with one hand, and with the other hand, I'm kind of stacking new objects on it. So I need to balance with one hand, and with the other hand, I'm doing these micro interactions and adding one after another. I don't know what it's for, but it does really nicely show that you can very nicely interleave both of the hands into this compound task. Yeah, and I'm also trying to fix this at some point, because it's already quite jittery. But yeah, even if you need this kind of precision, it still works, and you don't have to immediately grab into it. Yeah, until this happens. Yeah, so this is the last example here. And this is about more building things, more in the direction of Minecraft or bricks and Lego designs. But it could also be more into this 3D modeling interaction stuff. So So what I want to do here, I want to build a statue, so I'm stacking up the objects. And this also works quite simple. This is because I know exactly what to do with my hands, because it's the typical pinch gesturing. But what is kind of more invisible here is that you always have a sense of the environment. So even if it goes out of your reach, you know where's the object relative to the other objects, and you can stack them around and do these kind of interactions. Yeah. Okay. So in the next part, I wanna show you that we can. Because the previous examples were all about moving things around, resizing them, but of course this is not the whole thing. Usually in interface you have much more to offer, different kind of tools, different apps, different interfaces, and it's totally unclear how you would use your eyes with that kind of interface. So here I looked into VR literature, how were menus designed in the past. And I found two papers quite interesting. One is about proprioception, so how much are you actually aware of your body, and it's actually the fact that you always kind of know the relative position of your hands to your body, but also the relative position of one hand to the other hand. And this can be kind of utilized for the 3D virtual interaction. And others have suggested menus that kind of appear at the fingers or at the hands. So overall, the bigger theme here is that they are like body-based interface. So by using the body of the user, allows to add interfaces there where the user is always aware of them, where they are. So you can't get lost if the menu is somewhere in the virtual scene or something. So yeah, building on this, we looked at the following interactions. So here, this is kind of the whole system in one figure. On the very left side, it shows the basic interactions that you've already seen, so you can manipulate objects far away or close to you. But if you bring in your arm, on your forearm, there's a UI in a way. And it's like an armband or watch that is kind of attached to your arm. And you can interact with it using gaze and pinch interactions. And this kind of forearm menu is essentially like a system level menu where you can select between different tools and applications. And if you selected one of the applications, they can have an additional interface that is on your hand, like on the very right side here. So to actually use the application. Okay, I want to first focus on the more system level menu here. And this is designed in a way like a marking menu. And first of all, I want to show you, so the menu only appears when you look at it, as you can see. And when you look away, it kind of fades out again. So if it's not there, you can just interact normally with the virtual scene, nothing special. But if you're looking at it, then you can use some kind of gaze pinch interactions, as you can see in this one. So here, if I pinch, I get the center of the menu, and then I can go in any direction to choose one of the applications. So at the beginning, I'm just disabling the menu, and in another option, if I flick to the right, then I can select the map application here. Okay, now to the specific applications. So, yeah, and this is kind of a tablet-like interface. Imagine you're having your hand and there's a tablet or something, and there's been a lot of work into this in prior virtual reality interactions. But here I look into it, how it would work in the context of this gaze and pinch interaction. And if you think about menus, there are, of course, a lot of different types of menus. So we looked into 3 different groups in a way. So the first one is about allowing users very rapid access to the items on the menu, and the second one is about slower interaction, but where users require more precision. So if there are a lot of different tools and you have a big menu. And then the third one, we look at 3D interfaces. Okay, so the very first one, I hope this video is not too small. So this is about the quicker interactions. And if you pull up the hand, you will see this interface with just 4 options. It could be a bit more. And to select an item, you look at the item. So right now you see the circle on the block there. And then I can drag out objects from there. So I can immediately start using the gaze and pinch interactions because they are then attached to the hand. And here I'm just looking at the same target that's dragging out a lot of different objects. And this is the beginning of the other video, actually. Yeah, so this allows you can look at any of the targets and just do this pinch gesture, and you can drag out one of the targets. So of course, this was limited. You can only have a set of items there, depending on how accurate your eye gaze is. And I thought, okay, what if we want different interfaces with a lot of items? So this is just an example of a periodic table here. And you see there's a little cursor in the middle of the interface. So imagine it's like a, I don't know, Windows tablet or something like that. And the interaction is slightly different here. So eye gaze only selects the menu itself. And wherever you're looking on the menu, it doesn't matter. The only thing that happens when you use the pinch actions is this here. So when you move the cursor, right? So it's like a touchpad. You drag, and then you drag the cursor around. Okay. And if you perform this pinch action without movement, you can select one of the items. And the elements that were created are then generated at the position where your hand was actually pinching. And from that, you can immediately interact and do something else with it. Okay, so let's go on to the last example here. This is about 3D, a more 3D way of interface on your hand. And here it shows a mini-map of the whole virtual scene. And this is based or inspired on the Word in Miniature paper from a longer time ago. And in a sense, it allows, what they have showed is that you can have your own avatar in the interface and move that around, and then you can actually move yourself around in the real virtual scene. I'll show you the example, it makes more sense then. So here again, eye gaze only selects the interface, and when I pinch, I automatically select the red avatar. So that's like the small red dot here in the video. So I move it up, and then the locomotion happens, and the user moves the trajectory up to the position where the user was. And then you can do some kind of other interactions based on this better overview of the scene. Like this kind of stuff, what I've already showed before. And if you want to go back, you can bring out the map again and just immediately move your avatar to go to a different position. And so it's very easy to switch between manipulating things around, and then, okay, I want to move somewhere else. I bring out the map, I move, and so on. So yeah, there was a lot of different examples that I've showed, and I guess I still have a little bit of time to give a summary. So yeah, what we introduced here is an exploration of this gaze and pinch interaction technique. And it's interesting from the perspective of natural and supernatural or unnatural interfaces. It's kind of natural because it uses these familiar gestures. The users wouldn't need to learn anything because you know how to pinch, you know how to zoom. But at the same time, it goes beyond the typical gesture interaction because you can interact with anything that you can look at, right, in the whole scene, whether it's far away or close to you. So, yeah, we drawed out a design space showing these are kind of the atomic interactions, and based on these core interactions, we can build up from there a lot of different manipulation methods, such as these things where you do some, you can work with large scales, you can build some kind of basic 3D model or do this juggling-based interaction. And we also showed there are different ways to integrate eye gaze within this interaction style of gaze and pinch into different user interfaces. For either you want a very quick access, very precise access, or whether it's controlling something in a small 3D UI in your hand. Yeah, so at the end we had a user feedback session with 8 users, so they tried a lot of these things and gave some feedback. And most of them were like, it was really easy, so magical, this stuff. And of course they couldn't learn it immediately. It was kind of difficult. So one of the users said, for example, it was rather difficult at first to understand how the menu works. But after a couple of trials, they got the hang, and usually it was quite quickly. And there are some issues with false detection gestures. But there was, I'm not sure if this is the technique or if this is the gaze, the leap motion itself, because if you occlude fingers and all stuff, then there's some weird pinch detected and so on. Of course, there's the gorilla arm problem that was also mentioned yesterday. So as the user said, for example, it was tiring to keep the hands up, but even if they are not stretched at full length, thanks to the technique, so because you don't need to stretch your arms, but it was still, the user had to keep the arms in the range of the leap motion to make it really work, and there was still an issue if you want to interact for longer duration. Okay, I want to conclude the talk with the following points. Of course, eye and hand tracking needs to be improved to make this interaction really work. But nonetheless, I found it very interesting. There are a lot of underexplored potentials for eye tracking. Oops, sorry. Yeah, just the last 2 points. Yeah, we showed there are a lot of powerful ways of manipulation using this technique. And yeah, it's unclear whether it's really natural or whether it's unnatural and how this really works. And more studies are needed to clarify these questions. Okay. Thank you very much.
Thanks a lot. We have time for a few quick questions.
I think this is a very outstanding work, really, my compliments.
Yeah,
I have just one fear about this supernatural. So there is an important theme of this conference. So I know that pilots of airplanes, after a virtual simulator, they cannot cannot pilot for a few days, because a simulator cannot be exactly the real thing, Yeah. So why I say this? Because when you use a superpower in very near objects, probably you can transmit the habit in the user, which is not then real. So at the end, the user can go outside and have problems in coordination. So your system, it works very well. But there is the threat, the risk that the user then becomes completely scaring, dangerous in real life. So do you ever think about this problem?
Yeah, one solution would be to just stay in virtual reality.
I suggest forever. I just suggest to keep the interface is outstanding for faraway objects. I think is really revolutionary. Instead, I will keep a near object natural. So I can answer to your last line of probably you throw this question. You already prepared this question. So I think when you can have a natural interface and it works, like you have a very near object, I will say I will go for normal mapping, one-to-one, like mine says in his paper of '97. And when you are far away, then you can have supernatural power, It's like Spider-Man, it doesn't throw stuff all around. It's just when it's needed, it does it. Okay.
Really? Yeah, but definitely it's interesting. I'm not sure whether this is really natural or supernatural or whatever, because there are a lot of supernatural things in VR already, right? So, but yeah.
I'll second this is really great work. Do you have a Unity SDK or something like that? Because it would seem pretty easy to plug in, pretty generic.
Yeah, I don't know. It was it's quite easy to simply integrate the eye trick. So it's just, you know, an XY position and then.
You're better if you've already done it, though.
I'll think about it. Yeah, thanks.